Hello everyone, this is Nagar and I hope all of you are staying safe. Today I will represent our work which is neural embedding based metrics for pre-retrieval query performance prediction. So first let's see what is the problem of query performance prediction. The problem of query performance prediction in information retrieval community is defined as predicting the quality of retrieved documents in satisfying the information need behind the query. So if we use all these three input to address our question, it's called post-retrieval query performance prediction. On the other hand, if we do not use the list of retrieved documents in order to address the query performance prediction problem, it's called pre-retrieval query performance prediction. Pre-retrieval query performance predictors can be categorized into several groups based on the intuition behind them. We can categorize them based on similarity, coherency, term relatedness, and specificity of terms. Which the last one, the specificity-based pre-retrieval query performance predictors is the focus of this. Most of the state-of-the-art pre-retrieval query performance predictors are based on one simple intuition. Infrequent query terms are easier to satisfy. They're mostly based on statistical features of the terms and the frequency of the terms in the corpus. While they preserve statistical features of the terms, they have some disadvantages, such as losing semantic aspects of the terms, losing dependencies amongst terms. They are highly corpus dependent, and some of them might have complex calculation during index. That's why we came up to idea to propose a neural embedding-based specificity matrix for pre-retrieval query performance prediction. Let's move forward to our proposed approaches. We have few intuitions behind our work. We believe that more specific terms are more discriminative, therefore they represent easier queries. One other intuition is that a specific term is likely to be associated with many specific terms in its neighborhood, and since a more specific term represents a more precise semantics, therefore they're more likely to be surrounded by a higher number of specific terms. Here we can compare the structure of two ego network for arsenal as a specific term and soccer as a generic term. If we can if we analyze and investigate neighbors in these two networks, we can see that the neighbors to Arsenal as a specific term are more specific terms, like Everton, Tottenham, and Wenger. While in the ego network of a more generic term such as soccer, we can see football, which is also a more generic term. In order to measure the specificity, we measure the node centrality metrics to measure the importance of ego node in the ego network. We calculated several centrality metrics such as degree centrality, closeness centrality, and page rank. In total, we have experimented 7 different centrality methods to find out the importance of the ego node. In order to evaluate proposed pre-retrieval query performance predictors, we calculated Kendall and Pearson row correlation between the actual ranking of queries based on their map, their performance, and our predicted values. We try to predict the performance of query likelihood method, and for queries which contain more than one query term, we use aggregated functions such as sum, average, minimum, and maximum. We utilized a pre-trained word-to-vec model based on the Google News corpus, and we ran our experiment on Robust04, CoolWeb09, and Gov2, which are 3 well-known trails. So we can conclude our work in the following points. We've shown that it's possible to devise metrics based on neural embedding-based representation of term to address pre-retrieval query performance prediction tasks. We have shown that specificity of a query term estimated based on ego network presentation can lead to a better performance on query performance prediction compared to several state-of-the-art baselines. Overall, closeness centrality is our preferred metrics, but if there is some computation limitation, we can serve degree centrality. Thank you everyone for watching this presentation. This is my email and I'll be happy to hear your comments and questions on this work.